Hello and welcome to this course. Today we are going to learn very important topic for your examination perspective. So this from this topic there are the 2 marks or the 4 marks questions in NET and GATE examination. So we are going to learn what is molecular weight and how we are going to determine the molecular weight of the polymer. And we will also learn how molecular weight of polymer is different from the molecular weight of the simple molecule. So let's understand what is the molecular weight and why we are considering the distribution of the molecular weight of a polymer. So when we think about this molecular weight, maybe let's take example of suppose we want to polymerize this one. So we have styrene. Okay, let me make this one is little bit 1.5 and we have n number of molecule, and if that polymerizes and we have CH2, CH and the pH. So in this polymer, this polymerization happens, and if we have this polymer of the molecular weight, so here this polymerization is not always the same, where you have the same number of the lipid unit in each molecule of the polymer. So here N may be the 600, 800 or 700. So here N is not same for each molecule of the polymer. Maybe you have this one is shorter, maybe you have this longer, if you have the... So based on this kind of things, you have N is not fixed here. So from this one, N is not fixed. So if n is not fixed, that means there is different level of the degree of polymerization happens, and based on that, we will have different molecular weight, or maybe the number of its molecular weight. So if you want to know what is the n number of its molecular weight, so based on that, we will have this kind of the distributions, where if we just fit this data, we will have this kind of the Gaussian curve. And based on this Gaussian curve, where we have the number fraction of this molecular weight, and so based on this one, we will have the maximum distributions of this molecular weight. So we can say, okay, this is the molecular weight of the polymer based on the number fraction. So here that fraction is close to 22 10 to the power 3 gram per mole. So this is that is the based on the number fraction. So that is the number of its molecular weight. So now let's understand how we will define number of its molecular weight, that is based on the number fraction in the polymer. So number of its molecular weight we can determine based on, so here the number of its molecular weight is that how much number of the molecules of the polymer is present in a solution. That is called the number average. And for the number average molecular weight calculations, we can use osmotic pressure. So all the colligative properties. So all the colligative properties can be used to determine the number average, because these colligative properties depends on, so that properties depends on number of molecules, not weight of molecules, right? So all the colligative properties depends on the number of molecules. So based on one of the colligative properties is the osmotic pressure. So if we can use osmotic pressures, and based on that we calculate the number average molecular weight. So using the osmotic pressure, we will have the number average molecular weight So we can write the number of this molecular weight either in this way, or maybe we can write the number average molecular weight if we put the bar over mn. So that is also the number average molecular weight. So here this number average molecular weight is equal to summation over. So this is the summation over. We have mi divided by summation over ni ni. So here, so this ni. So here this Ni may be the number of moles or maybe number of molecules. And here Mi is that molecular mass of species I. So here we have the either the number of the moles or the number of the molecules, and we have the molecular mass of the species I. So here, suppose we have the maybe 10, so or maybe it's 2. So based on that, if we have here, suppose we have a 2, so we have n1 m1 plus n2 m2 divided by here we have the n1 plus n2. So based on this one, we can calculate what is the number average molecular weight of the polymer. And in some problems, you may have the number of moles. So here the number of mole is, so I put the number of mole and the molecular mass, so we'll have this one. And suppose in some problem, if you have the number of the molecules, suppose here n is number of molecules. So we can divide, convert that number of molecules into the number of moles by dividing Avogadro's number. So that becomes number of moles. Number of moles. So based on this number of moles, we put this one here. So we will get the number average molecular weight of the polymer. And further on, here from this equations, we have summation over ni mi. So this is the number of moles, and here is the mi. So here the upper term will be the weight fraction, and summation here we have the number of moles. So we can use either this relation or maybe this relation where ni or mi that will becomes, so that will become wi, and here ni, so that is the number of mole. So that number of mole is equal to weight of that molecule divided by the molecular weight. So using either these equations, we can calculate the number average molecular weight of the polymer. Now let's understand what is molecule weight average molecular weight of polymer. So for that, as I explained earlier, that if we have this polymer, and suppose again, let me explain with the same example. If we have CH2, CH, and pH. So in this example, we understand from the last example that here the N is not fixed in the polymerization process. So if N is not fixed, then the molar mass of that molecule is not fixed. So if we have the different length of the polymers, and so based on that, we will have there's a distribution of that molecular weight. And so if we plot the fraction of the molecular weight fraction and the molecular weight of the polymer, so based on that, we will have this kind of Gaussian curve. And based on this Gaussian curve, we will have this is that's values that is close to here. Maybe from this one, we will have 20, 23, or maybe 24,000 gram per mole. So based on that, we will have the we have calculated this one using the weight fraction of this molecule of the polymer. So if we use the weight fraction and based on that we calculate the molecular weight, so this becomes as the weight fraction or the weight average molecular weight. So we have the some definite formula for weight average molecular weight. So we can calculate that weight average molecular weight using light scattering technique because this technique is sensitive to size of molecules, not number of molecules. So the light scattering technique only depends on the size of the molecules rather than the number of the molecules as in the case of the qualitative properties. So if we use light scattering technique, so using this technique we can calculate weight average molecular weight. So now let's understand how we calculate weight average molecular weight. So here we can write weight average molecular weight either this way or maybe we can write here this way, either this way or maybe this way. So the weight average molecular weight is equal to summation over I Ni Mi square divided by Ni Mi. So here Ni or Mi. So let me write here. Here is summation over Ni Mi square and divided by Ni Mi. So here Ni and Mi. So this is number of mole and this is molecular weight. So here, so that becomes is the weight of the polymer. And so we have this Wi Mi divided by Wi. Suppose we have this two component here, so we can write here W1 M1 plus W2 M2 divided by W1 and the W2. So based on this formula, we can calculate what is weight average molecular weight of the polymer. And we have other kind of the molecular weight that is Z average molecular weight. So Z average molecular weight is even though higher than the molecular weight average molecular weight. And we can calculate molecular weight using ultracentrifugation technique. So using this technique, we can calculate that is the Z average molecular weight, maybe Zm. So using this technique, we have here summation over Ni cube summation over Ni square. So here we can write here summation over Ni and Mi square, and we will write here summation over Ni Mi and Mi. So here this term becomes summation over Wi Mi square and divided by summation over Wi Mi. So this is about the Z average molecular weight. So till now we understand three kinds of molecular weight, and this molecular weight is depends on the which technique we are using to calculate the molecular weight of the polymer. So now let's understand what are the relation between these different molecular weight of the polymer. So based on this plot, if we plot the fraction of the molecular weight with the molecular weight of the polymer, so we would have the number of its molecular weight, the weight of its molecular weight, and the Z of its molecular weight. So using that distribution curve, we will have the here Mz is has a higher molecular weight as compared to here the MW molecular weight and the number of its molecular weight. So based on this distribution curve, we will write the increasing order of the weight of the polymer. So here, JW's molecular weight is greater than the weight of its molecular weight and the number of its molecular weight. So, so this is about if you have the heterogeneous polymer solution. And if we have the homogeneous kind of the polymers, in this case, we will have these all polymers molecular weight are same. So we will have the Mz is equal to Mw and Mn. So we have one important parameter that is heterogeneity of the polymer. So now let's understand what is the heterogeneity of the polymer, or maybe we can write is the polydispersity index PDI. PDI is very important parameters on which we can understand whether the polymer is heterogeneous or not. So here the PDI defines as the ratio of weight of its molecular weight divided by the number of its molecular weight. So if we understand, so we have this one is number of its molecular weight and this is the weight of its molecular weight. So what is distribution of MW with respect to the Mn, that is the PDI. So if these two molecular weights are far away from each other, that means the PDI is more greater than 1, and that's more and more. That depends on the how these two are the far away from each other. So in that case, you have the more heterogeneity of the polymers. So, and if you have these two distributions as very close, so in this case, MW and Mn both are in close to each other, and in this case, this PDI is close to 1. So if PDI close to 1, in this case, we can say it's the monodisperse polymer. So for this is the monodisperse case. And if PDI greater than 1, so this is called heterodisperse, disperse, or heterogeneity in this polymer. And this is very important parameters from where there is maybe 2 or the 4 marks question in CSIR or maybe GATE examination. So you should be careful about of this topic. Now let's solve some numericals based on these important parameters. So first question here is, suppose you have the polymers sample consisting of 9 moles of the molecular weight, 30,000, and 5 moles of molecular weight of 50,000. We need to calculate Mn, Mw, Mz, and the PDI. So now let's understand what is given in this problem. So here is given is that we have N1 is equal to 9 moles. We have N2 is equal to 5 moles. We have M1 is equal to 30,000 and M2 is equal to 50,000. So using the formula, we have Mn, number of its molecular weight, is summation over Ni, or maybe I should write Ni, Mi summation over Ni. So we will write here N1, M1 plus N2, M2 divided by N1 plus N2. So if we put these values here, we will have 9 into 30,000. We have 5 into 50,000, and we divide by 9 plus 5, and we will solve this one. So that becomes the Mn values. Again, we will solve this one for, so if we use MW, so if we use the MW, so MW is equal to Mi squares divided by summation over Mi. So will write here, we'll have N1 M1 square plus N2 M2 square divided by N1 M1 plus N2 M2, and we put the values here. So we will have N, and we have 30,000 squared plus we have 5 into 50,000 squared, and we will have here 9 into 30,000 and plus 5 into 50,000. So if you solve this one, so we will have MW values. Similarly, you can calculate MZ values, and if you have Mn and MW value, then we will calculate PDI, and this PDI is defined as here MW by Mn. So if we put these values here, we will get the PDI values. So this kind of the questions maybe come in the examination, or maybe, so now let's understand the second question. So in the second question, we have here weight is given of molecular weight. So we have given here W1 is equal to 9 gram and W2 is given 5 gram, right? And we have M1 is given 30,000 and M2 is given 50,000. So if we use the formula here, so if we have Mn, number of molecular weight of polymer, so this formula is summation over Ni Mi, so and divided by summation over Ni. So we can write this formula is summation over Wi, and here divided by summation over Wi and Mi. And we will have here we will write here Wi. So we have from this one W1 plus W2, we will have W1 divided by M1 and W2 by M2. And from this one, we will have 9 plus 5 divided by 9 divided by 30,000, and we have 5 divided by 50,000. So if you solve this one, you will have Mn values. And similarly, we can calculate MW, and that is summation over Mi square divided by Ni Mi. So we can convert this one into the summation over Wi Mi and divide by Wi. So this becomes as W1 M1 plus W2 M2 divided by W1 plus W2. And if we put these values here, so we'll have 9 into 30,000, we have 5 into 50,000 divided by 9 plus 5, and we will have here MW values. And once we get these values, then we can calculate PDI is equal to MW divided by, if we put these values from here to there, we will get the PDI values. So either we have here number of moles given in this problem, or maybe we have given the weight of the polymer. We can calculate number of its molecular weight of polymer, or maybe the weight of its molecular weight of polymer, and from that we can calculate what is the PDI value or poly viscosity index. We have a similar problem here. If you think about this similar problem, so we have here amount is given. So we have W1 is given, M1 is given, W2, M2 is based on that. So from this problem, we have W1 is given 1 gram, W2 is given 2 gram, W3 is given 2 gram, and we have M1 is given 10,000, M2 is given 50,000, and M3 is given 100,000 molecular weight. And based on that, we will put these values as in the previous problem, and we will calculate Mn, Mw, and the PDI values. Hope you can solve this problem. We have the different kind of the problem here. So this is maybe the important problem. So in this problem, we have molecular weight of the polymer, and the ratio is given. So based on that ratio, we need to calculate Mn, Mw, Mz, and PDI values. So here we can calculate. So we have the ratio is given. So based on that ratio, we can calculate Mn. So here maybe we can calculate using, suppose if you have taken the number of the moles of this one, so we have summation over Ni, Mi, and so divided by summation over Ni. So we will write here N1, M1 plus N2, M2 plus N3, M3, N4, M4 divided by N1 plus N2 plus N3 plus N4. So we have here 1 into 100,000. We have N5 into 200,000. We have 3 into 500,000 plus we have 1 into 1,000, and divide by we have 1 is to 5 is to 3 is to 1. Based on that, we will calculate what is the number average molecular weight. Similarly, we will calculate MW values, and so we will have here summation over Mi square by divided by Ni. So we will have, let me write with a different color. So we have N1, M1 square plus N2, M2 square plus N3, M3 square plus N4, M4 square divided by N1, M1 plus N2, M2 plus N3, M3 plus N4, M4. So if you solve this one, we will get the MW values, and again we can calculate what is the PDI based on, sorry, based on the ratio of the weight of its molecular weight divided by number of its molecular weight of a polymer. So this is very simple problem. And we have another kind of problem here. So this kind of problem, question number 5 and 6. So that, so these are questions was in gate examination in couple of times. So you can calculate what happens. No, sorry, we have technical problem. Sorry, there was some technical problem. Okay, now let's understand how we will solve this problem. Now let's understand how to solve this problem. So in this question, we have the equal number of molecules of molecular weight is given M1 and M2. Now we need to calculate what is Mn, Mw, and PDI values. So this question is very important for your exam perspective. So in this problem, we have the equal number of molecules. So for this kind of problem, we will let's consider number of molecules. Number of molecules. So we'll just consider the number of molecules, maybe 10 or maybe 100. Now consider the number of molecules is 100. And based on that, we will have here the, so we have here the N1 is given 100, we have N2 is 100, and we have M1 is 10,000 and M2 is 100,000. And based on that, we will use formula. So we will have N1, M1 plus N2, M2 divided by N1 plus N2, and we will have 100 into 10,000 plus 100 into 100,000 divided by, we have here 100 plus 100. So if you take the common of 100 and 100, so what happens? We have 10,000 plus 100,000 divided by 2. So here, if you just consider the equal in the arbitrary number of molecules, so in this case, that will cancel out and you will get the Mn values. Similarly, we can calculate using for same, we will calculate Mw, and for this one we will have here N1 M1 square plus N2 M2 square divided by N1 M1 plus N2 M2. And if we put the values here, so we'll get MW values, and PDI will calculate using MW by MN. So based on that, we will calculate what is PDI values and heterogeneity of sample. Now let's understand how we will solve problem. That is again, this is again important problem for exam perspective. So in this problem, okay, so in this one, equal number of molecules. Suppose in this problem, equal masses is given. So in this problem, we have the equal number of molecules is given. Now, if we have the equal masses of the polymers is given, and this has the molecular weight 10,000 and the 100,000. So here, mass, both kind of the molecule have the same mass, has same mass. So for this one, we will just consider the arbitrary masses. So we'll write here, consider mass of polymer maybe 10 gram. So we just consider arbitrary number is 10 gram here. So we'll have here W1 is 10 gram and W2 also is 10 gram, and we have M1 is 10,000 and M2 is 100,000. So we have WM1. So based on that, we will calculate M number of molecular weight. So here we have the formula NIMI squared divided by NI. Sorry. So this column, okay, there was error. So if we write this one, so what we have? So we will convert this one into summation over Wi, and we will convert this number of mole into summation over Wi by Mi. So we have here W1 plus W2 divided by W1 by M1 plus W2 by M2. So here we have 10 plus 10, and we have 10 divided by 10,000, and we have 10 divided by 100,000, and we will solve this one. We will get number of molecular weight of polymer. Again, we will solve this one and we will get what is MW values. So for this one, we will have NIMI squares divided by summation over NIMI. So we can convert this formula into WIMI divided by WI. So we have here W1 M1 plus W2 M2 divided by W1 plus W2. And we have here W1, we have 10, and M1 is 10,000. And we have here 10 into 1,000. And if we divide by this one, so we have MW values. And if we get the MW value, then we can use this formula. PDI is weight of its molecular weight by number of its molecular weight, and we get the PDI values. So if we have the equal number of, so equal masses, or maybe if we have the equal number of molecules, we will have this kind of this solution. We can also see the next kind of the example. Here we have one kind of polymers which has 10% by weight of the macromolecule of the molecular weight 10,000, and 90% by weight of the molecular weight with the molecular weight of 100,000 calculate Mn and Mw. So here you have weight fraction. So it's 10% of weight fraction. So for that, we need to use, you just consider maybe 10 gram of mass. Just consider 10 gram. So in 10% means 1 gram, and the 90% means the 9 gram. So you have W1 and W2, and you have here M1 is 10,000 and M2 is 100,000. So you have W1, W2, M1, and M2. So if again you should use the formula and calculate what is Mn and Mw. We have another kind of problem here. So that is the in a polymer there are 100 molecules of the molecular weight, hundreds, 20, 200 molecules of the molecular weight, 10, 1000 and 300 molecules of molecular weight of 10,000. Find Mn, Mw and the PDI. So here we have given is the number of molecules. So if you write the number of molecule is 100. And we have, so here N1 is equal to 100 and M1 is 100. N2 is 200, M2 is 1000, N3 is 300, and M3 is 10,000. So we have this information. So if we use the formula for number of its molecular weight of its molecular weight, and PDI, we will have these values. So in this course, we have these two assignment. One assignment is there. So based on the distribution curve, we need to put this one in ascending order, descending order. So the Mn is the number of its molecular weight, Mw is the weight of its molecular weight, Mz is Z of its molecular weight, and Mv is viscosity average molecule. So here this one is viscosity average molecular weight. So if we have this one, so based on that we'll put this one. So in this case we will have, so we will have Mz, then we will have Mw, then we will have Mv, and we have Mn. So this is the sequence that is based on distribution. And we have a problem here where we have this polystyrene sample which is given, and Mn and Mw is also given, and we are adding 1 gram of monodisperse polystyrene sample which has Mw, Mn is 10,000, Mw, Mn 30,000, Mn 45,000, Mw, Mn is 60,000. So here we need to find out the new molecule Mn and Mw values. So we have the two kind of the sample. We have previous sample is amount is given 10 gram, and Mn is given is 30,000, and Mw is given 60,000. So we have this sample. So we have sample number 1, and we have the sample numbers 2. In sample number 2, you take this example for first. So we have here W2 is 1 gram, and we have Mn is equal to 10,000, and Mw is also 10,000. So if we mix for this one and this one, so what happens? So we need to find out new Mn values, new Mw values, and if we find the new values of Mn and W, we need to know how these values are different from these initial values. So that is the question: mix lower or the higher in the between which will change more in terms of the percentage. So we need to find out what is the percentage of new one minus this one, the previous one. In the second problem, we have 10 gram of polystyrene sample. So that is given. So again, we have W1 is given 10 gram, and we have Mn is 30,000 and MW is 60,000. So we have one sample and we have other sample that has the 1 gram. So, so W2 is given 1 gram and which we have the Mn is given. So here Mn is given 20,000 and PDI is given 2. That means you have MW and that is how much? So here we have PDI is equal to MW by Mn and here Mn is given. So based on that, we will have MW is equal to PDI into Mn and here 2 into 20,000. So here will be the 40,000. So again, you are mixing 1 and 2. If you mix these two, we need to know what is new Mn and Mw values. And we need to know what are the percentage change from first one, right? So using this kind of problem, you understand if you want to make blending of these polymers. So this kind of the calculation is useful. So here the application of this kind of the problem is to make blend of polymer. So if you have the polymer A kind and polymer B kind and if you're mixing together, so that is called the blending of the polymers. So if you blend the polymers, in this case, we need to know what is the molecular weight of the polymer. So from this one, we need to know what is the molecular weight, and based on that molecular weight, glass transition temperature, that is glass transition temperature and mechanical properties. Mechanical properties depends on. So if you want to make the new kind of the polymer and control the mechanical property or maybe glass transition temperature, so we need to know how much we need to have tolerance in the change in molecular weight if you mix in these two kind of the polymer. So in assignment, both questions are very important in the research perspective. Now let's understand one key aspect, and that is the degree of polymerization. Excuse me. We have another very important topic, that is degree of polymerization. So here degree of polymerization, so that is the measure of the number of monomer units in the chain. For example, so suppose these are the monomeric unit. Excuse me. Degree of polymerization is very important topic. So now let's understand what is degree of polymerization and how we will calculate degree of polymerization. Suppose we have these other monomers, and if that monomers combines together and that forms the polymer. If take example here, if you have CH2, CH and X. So if you have the n number of monomer and it forms polymer. So we want to know how many these monomer units polymerization and forms the polymer chain. So if you want to know what is the polymer chain, what how many number of molecules of each monomer reacts and that forms a polymer. So here N is the number of repeat unit and maybe the number of monomer that reacts and that forms the long chain of the polymer. So here we can write here in this entire polymer the number of the repeat unit is equal to the number of structure unit, and that is a degree of polymerization because here degree of polymerization is the kind of the number of monomers unit in the chain, and N is the and here number of repeat unit, and here the number of repeat units is N, and that is degree of polymerization. So so if we have the kind of the homopolymer, so in homopolymer, in homopolymer, for example, if we have this polyvinyl chloride, this is the mono, and this is the polymerizations happens to it, and this is Teflon kind of things, and here we have the polyethylene, and we have kind of things in. So in homopolymer, the number of the repeat unit, or maybe the number of molecules that forms the chain, long chain of polymer, so that is the degree of polymerization. So now let's understand with the problem how what is the degree of polymerization. For example, let's consider this one, PVC. Find the average degree of polymerization for the following polymers with the average molecular weight of 100,000. So here we have given molecular weight of the polymer is 100,000. And based on that, we need to find out what is degree of polymerization, degree of polymerization. In other way, we need to know what is the number of, what is the values of N. So what is the values of N? So if we know how many monomer unit polymerizes is, then we will have the degree of polymerization. So for that, we need to know what is the molecular weight of mono. So now let's calculate molecular, sorry, molecular weight of repeat unit. So if you want, so here in the repeat unit, we have CS2, so we have 12 plus 2, and we have carbons 12, and we have chlorine, so 35.5 into 2. So you have 14, 14 plus 12 plus 31. So we have 4 to 6, 7, 4 to 6, 7. We have 7, 8, 9. 4. And we have here, so we have the 97. And once we have the 97 and we have the here, so we will calculate what is, so here the molar mass, molecular mass is equal to, here we have the 97 into N, where N is the number of the repeat unit, and that is equal to 100,000. And if you want to calculate what is the N values, we have divided by 97. We will get the values here. So based on this, we will calculate what is degree of polymerization, and this values is degree of polymerization. For now, we just consider first one and the third one. So again, in this kind of the polymer, this is the homopolymer. So this is also example of the homopolymer. So if we take this homopolymer, again, we will calculate. So here we need to calculate what is the molecular weight of the repeat unit. So let's consider M0. So if we have the molecular weight of the repeat unit M, and here N is the repeat unit, and that is equal to the 100,000. And we will calculate N values here, 100,000 divided by M0. So we will calculate the M0 values based on the structures, and this is equal to the degree of polymerization. So here, based on this degree of polymerization, we will know, okay, how many monomer is polymerizes is polymerizes polymerized, and that forms the polymer. So now we have a different kind of structure of polymers, and that is copolymer. Copolymer. So in homopolymer, we have a single kind of monomer repeat unit, but however, in the copolymer, we have this two kind of repeat unit. So we have this two kind of this two kinds of here monomer, A and B, and then combines and then forms A and B kind of polymer. For example, we have here, this is kind of A polymer, maybe AA, and we have this is the B kind of the monomer. So if A monomer A and B combines, and that forms here up to here, this is A, and from here to here, this is B. So this is the example of the copolymer. So in polycarbonate, we have the A kind of, and this is the B kind of things. So up to here, we have B, and only this one comes from A. So this is also example of the copolymer. So in copolymer, what is there? So each repeat unit. So we have A and B reacts, and that's form the A and B. So each repeat unit, we have this two structural unit, right? So the number of the repeat unit is just 2 into the structural unit. And based on that structural unit, we need to find out if you have the repeat unit and the number of the structural unit. So here, number of structural unit is equal to repeat unit divided by 2, because each repeat unit, they are two monomer, right? We have A and B kind of things. That's why we need to divide by just 2 into the repeat unit, or maybe the number of repeat unit is equal to 2 into the structure unit. We have the A and B both of things. Based on that, we will get the structure unit, and this is the degree of polymerization. So based on the polymerization, copolymer, or the homopolymer, we will calculate what is the degree of polymerization. So now let's understand how we are going to calculate degree of polymerization. So from previous problem, we have solved this one. We have already solved this one. This is homopolymer, homopolymer, and this is also homopolymer, homopolymer. This is copolymer, copolymer, and this is also copolymer. Because here we have the one repeat unit, and up to here, this is the second repeat unit. Here we have the one kind of repeat unit, and this is the second uh, kind of the monomers there. So in homopolymer, the number of N is called degree of polymerization. Again, here number of N is called degree of polymerization. However, here we need to find out what is the number of N. So for that, we need to know what is the molar mass of the repeat molecular mass of the repeat unit. So let's understand, suppose we have M0 molecular mass of a repeat unit. So from this one, we have M0, and we have N. So from this one, we will know what is the number of repeat unit, and we have the molecular weight is 254,000. So here we calculate what is N value is 254 divided by M0. And we calculate M0 for this one, for this one, and if we get N values here, so that is the repeat unit. So we will further divide with the, if we want to degree polymerization, so that is N by 2, and that is the degree polymerization. For example, now let's understand what is degree polymerization. We have in the first problem 9, we have polystyrene of molecular weight is given there. Now we need to find out what is the degree polymerization. So here for the problem number 9, we need to first write the reaction. We have polystyrene, and that forms polymer. So if that forms polymer, and this polymer has molecular weight, sorry, this is M, that is 10 to the power 5 gram per mole. So here we need to find out what is molecular mass of the repeat unit. So here we have the M0 into N here, and this is 10 to the power 5, and N is equal to 10 to the power 5 divided by M0, and that is the degree of polymerization. Again, in question number 10, find MW for PP gives this degree of polymerization is 10,000. So for the question number 10, we, this is PP for the polypropylene. So first we need to write things here, CS2. So if that polymerizes, so it forms CS2, CS3, polypropylene things here, and the molecular mass is given 10,000. So here we need degree of polymerization. Oh, sorry, given its degree of polymerization. So sorry. So here degree of polymerization is given. So here we have in dp is given 10,000, and we need to find out what is the molecular weight of the polymer. So for this one, we have degree of polymerization. So n values is given here, and we need to find out what is the m naught values for this one. So m naught is equal to 12 plus 15 plus 12, 13 plus 14. So this is gram per mole is the m naught values. And from this m naught values, we will have mw is equal to m naught into dp, and that is m naught into 10,000. So that is the molecular weight of the number, variable molecular weight of the polymer. We have another problem, that is we have here 42 grams of propylene was polymerized by the radical polymerization process, and dp was found to be 1,000. We need to find out what is the number of molecules of the pp produced. So in this case, we have dp is given 10,000. So first we need to write what is polymerization reaction. So we have CH2, we have CH3. So based on, if we calculate, oh, sorry, if we calculate this one, we will have such a, so here the degree of polymerization. So here degree of polymerization is given that n is equal to 1000. So for this one, we will calculate what is the molecular weight of the polymer. So from this one, we need to write here, and for this one, we will calculate what is the M naught values. So this M naught is equal to, this is 12 plus 3, 15 plus 13 plus 14. So this is gram per mole. This is the M naught value. And from this M naught values, we will calculate what is molecular weight of the polymer. So here we will calculate M naught into degree of polymerization. So here M naught into 1000. So this is the M naught values. And now we have here the propylene. So we have here the number of, so here the gram is given, or maybe this amount of this propylene is given here. So from this propylene, we calculate the what is the number of moles. So from this one, we will have 42 gram divided by 42 gram per mole. So this is 1 mole. And based on this number of moles, we will find out what is the molecule number of the molecules of the PP produced. So this is all about the degree of polymerization and the molecular weight of the polymer. This is very important topic for your exam perspective. So thank you very much.